Alright, continue what we have done previously on chapter 9.2. So today we are on the unsaturated hydrocarbon. We have talked about alkene, which is an example of an unsaturated hydrocarbon. So this is on alkyne. So when we are talking about alkyne here, they say that they are homologous series of hydrocarbon with molecules containing one carbon-carbon triple bond. So this is the general formula of alkynes with one triple bond, which is CnH2n-2, and it says here the presence of a carbon-carbon triple bond means the alkynes can also be described as unsaturated molecules. The names of alkynes end with Y and E, and see the arrangement of the atoms around the CC triple bond is linear. So once again, there is a difference between alkane, alkene, and alkyne. So in this case, when we are talking about alkyne, we are referring to that particular hydrocarbon having a triple bond, which is why the formula that we have here is CnH2n-2, which is different from alkene, which is another example of an unsaturated hydrocarbon. But for alkene, the formula that we have is CnH2n. So in this case, the formula that we have for alkyne is CnH2n-2. Moving on to the next slide. Alright, so as you can see here, we have different examples of alkyne. The first alkyne, or the simplest alkyne that we have, is ethyne, and then we have propyne, and then we have butyne. So if it's ethyne, the formula is C2H2. If it's propyne, the formula is C3H4. If it's butyne, the formula is C4H6. If you look at the molecular formula for alkyne in general, it follows the molecular formula, which is CnH2n-2. Let's just say if the number of carbon is 2, the number of hydrogen will be 4 minus 2, which is 2. How do we get this particular molecular formula? If you look at the structure itself, you can see the similarity between ethyne, propyne, butyne is that all of them contains one triple bond, as you can see here. So the triple bond shows that 3 valence electrons are being shared by each atom. That's what it means. If you look at the properties here, in ethyne, it says that they are colorless gas, slightly soluble in water. For propyne, it's colorless gas, slightly soluble in water as well. And in butyne, you either get a gas or liquid, depending on which isomer we are talking about. So we did mention, or we did discuss the structural isomer, which means that they have the same molecular formulas, but different structural arrangement. You can see that the boiling point actually increases, and bear in mind, these are non-polar molecules because they only consist of carbon and hydrogen, and we know that if it's a non-polar molecule, it contains only one type of intermolecular force, which is in the form of dispersion force. So in this case, if the number of carbon increases, the boiling point increases because the strength of the intermolecular force in the form of dispersion force increases as well. So when we are talking about uses in ethyne, it's used for welding. So they can be used for equipments that are of a very high temperature, or use that is very high temperature. For propyne, they're used for rocket fuel, and for butyne, they're used as a reactant in the synthesis of other organic compounds. So there is a general idea of what alkynes are. Moving on to the next slide. So make sure you know the difference once again between the molecular formula, the electron dot, which is the Lewis structure, the condensed structure formula, and the structural formula. If we look at ethyne, for example, you know that the structural formula looks something like this. You have 3 valence electrons that has been shared by each carbon. You know the condensed structural formula will be CH. For propyne, the structural formula once again, it shows the 3 valence electrons that have been shared by each carbon in the center, as you can see, by that particular 2 carbon atoms, and the condensed structural formula here will be CH3. So that is the general idea. Make sure you know the difference once again between the electron dot diagram. Electron dot is the Lewis structure. The structure formula is very similar to the valence structure that we have discussed. The only difference is that the structure formula, it shows the bond, which is similar to what we have discovered in the valence structure, but structural formulas, they do not show the valence electrons. And then we have the condensed structure formulas that actually do not show the bond. But they do show the carbons and hydrogens that are present within that particular compound. Moving on to the next slide. Alright, so this slide here is talking about the structural isomers of alkyne. So when we talk about structural isomer, once again, we are talking about molecules that have the same molecular formula but different structural arrangement. Same molecular formula but different structural arrangement. So when we are talking about the structural isomers of alkynes, we see that they contain more than 3 carbons. So for structural isomers to exist in the alkyne structure, alkyne molecules, they have to contain more than 3 carbon atoms. So if they have 4 carbon, 5 carbon, and so on, it means that they do have a structural isomer. It says that some isomers have branches on the carbon chain, while other isomers have the carbon-carbon triple bond in different positions. So you have pen-1-ine, you have pen-2-ine, and you have 3-methyl-but-1-ine. So the difference, as you can see the triple bond is in different location. If it's pen-1-ine, the triple bond is on the first carbon, as you can see here based on what I've circled. If it's pen-2-ine, you know that the triple bond is on the second carbon. If it's 3-methyl-but-1-ine, you know that the triple bond is on the first carbon, but at the same time, they do contain that particular branch or side chain, which is the methyl, as you can see, the CH3, which is what I'm going to highlight here. That is the methyl structure on the third carbon, so that is known as the 3-methyl-but-1-ine. So you can see that difference in that particular location of the triple bond and the presence of the side chain can influence the boiling point of that particular structure. In general, if they do have a side chain once again, they will make that particular structures more compact, which means that you have less surface area with another molecule. Ultimately speaking, the boiling point will reduce as a result. Because of the lower surface area, there's lower intermolecular forces between one molecule and another, the boiling point of the structure will decrease. Moving on to the next slide. Alright, so how do we name alkenes and alkyne? We have discussed alkene in the last class, so today we have looked at alkyne. So the general rules of how do we name alkenes and alkyne, we have number 1. And this is based on, once again, the IUPAC name. What does IUPAC stands for? That's the International Union of Pure and Applied Chemistry system. And it says here, there is a set of rules that needs to follow in order for us to name alkenes and alkynes. So step number 1, identify the longest unbranched carbon chain. It says that for alkenes, the chain must include the double bond, and for alkynes, the chain must include triple bond. Number 2, it says number the carbon atoms in the chain from the end of the chain that will give the smallest numbers to double bonded and triple bonded carbon atoms. Number 3, name the alkyl groups after the alkane from which they are derived. Number 4, identify the position of the double bond or triple bond by the number of the first carbon involved in the bond. Use the suffix E and E to indicate the presence of double bond. If you have Y and E, you need to indicate the presence of triple bond. And number 5 is list the number and position of each alkyl groups at the beginning of the compound state in alphabetical order. And number 6, if 2 identical side chains are present, use di as a prefix, and use if it's 2, use tri. Alright, so something for you to consider. Once again, there's a lot of words here, so let's show you some examples that we have. Moving on to the next slide. So as you can see here, based on what is written on the textbook here, so what is the name of this particular structural isomers of hexene? So if you're talking about hexene, it has a double bond. Can we say there's a double bond? So in this case, it is a structural isomer of hexene. So it's not hexene, or it has a different name, but it has the same molecular formula as hexene, which means that in this case, hexene, the structural isomers of hexene contains 6 carbon. And based on the molecular formula of alkene, which is CnH2n, we know that the molecular formula of hexene has to be C6H12. C6H12. So what you need to do here, once again, step number 1, identify the longest chain that contains the double or triple bond. The name of the molecule is based on this chain. Number 2, number the carbon starting from the end closest to the double or triple bond. Number 3, name each side branch and the number of carbon that is on. So once you have identified the double bond, you look at where the particular side chain or branch is. So you know there's a methyl. In this case, it's on the 4th carbon. Some of you may be saying that, hey, why is it not on the 2nd carbon? The reason for that, because when you're counting the carbon or the number of the carbon, it has to begin from the end that is closest towards the double or triple bond. So in this case, the double bond is on the second carbon. So and the fourth carbon here that is attached to a methyl group has to be the side chain. So the name of this particular structure or structural isomers of hexane is 4-methyl-pentane. 4-methyl-pentane is the structural isomers of hexane. So 4-methyl-pentane. So it's not hexane, it's known as pentane because the main chain consists of 5 carbon and there is a side chain on the 4th carbon, so it's known as a 4-methyl-pentane. Moving to the next slide. Alright, so continue on this. So we were talking about the interaction unit of pure and applied chemists system. So in terms of the naming system of unsaturated hydrocarbons, so as you can see here, there's a few structures here. The first structure contains a double bond, as you can see here. So this particular structure has a name which is 3-methyl-butane, and the reason for that is because it contains that double bond on the first carbon and a methyl group on the third carbon, as you can see here. If you look at the second structure, as you can see here, it's known as the 2,3-dimethylbutane, 2,3-dimethylbutane. So you can see that, and in this case, you have a double bond. You have a double bond on the first carbon, but at the same time, it has a side chain of a methyl group on the second and the third carbon. Can we see that? If I'm going to highlight this for you, on the second carbon, it has this methyl group, and on the third carbon, it has this methyl group, as you can see here. So this particular structure has the name of 2,3-dimethylbutane. And the third structure, which is the last structure that we have on this diagram here, we know that this is known as 3-methylbutane. So this is an example of an alkyne structure. So 3-methylbutane, as you can see here, it has a triple bond on the first carbon. At the same time, it has the methyl group, so the acetyl group in the form of a methyl group on the third carbon. Can we see that? So this is an example of a 3-methylbutane. Make sure that when you are naming the system, the double or triple bonds must be prioritized here first. So in terms of your naming, you must base it on the double or triple bond followed by whether the methyl group or any other acetyl group is present as a side chain. If that is the case, then you have to include it into your naming as well. Alright, so something for you to consider. Moving on to the next slide. Alright, so we do have a question here and they give you an example of this particular structure. So make sure you know how to name this structure. As you can see, write the system name of the following molecule of an unsaturated hydrocarbon. We know that the main chain consists of 5 carbon, as you can see, and the second carbon contains the double bond. Can we see that? If I'm going to highlight this for you, I'll put a circle here. The second carbon contains the double bond, and at the same time, we know that the third carbon contains the methyl group, which is something that looks like this on the diagram. So the name of this particular structure here has to be 3-methylpentane. Can we see that? 3-methylpentane, because the main chain consists of 5 carbon. On the second carbon, we have the double bond, and on the third carbon, we have the methyl group, which is the side chain, as you can see. So the name of the particular molecule has to be 3-methylpentane. Moving on to the next slide. Alright, so we can continue on this particular question that I need to work on this question. So in this case, you can see the longest unbranched chain contains 4 carbon. There is a double bond on the first carbon. So some hint or some clue for you to think about before we discuss more of this in class. At the same time, you also have a methyl side chain on the second carbon and a methyl side chain on the third carbon. So something for you to consider once again. When you are naming this particular structure, once again, you have to prioritize the alkene structure. So in this case, the alkene structure contains 4 carbon in the longest unbranched chain in the center, followed by the branch or the side chain. So this has to be a butane structure, but it has a double bond on the first carbon, so it probably has to be butane. and then you have to add on the side chain. In this case, you have a methyl side chain on the second and third carbon. So the name most likely has to be 2,3-dimethyl but 1-ene. So think about whether you have that answer. And make sure you know the difference between alkane, alkene, and alkyne. So once again, when we're talking about an alkane structure, the molecular formula of an alkane structure has to be CnH2n plus 2. Alkene will be CnH2n, and alkyne has to be CnH2n minus 2. So in this case, it contains that particular double bond, so most likely it is an alkene structure, and think about the naming of that particular molecule. So I'll see you back in class. If you do have any questions, you're welcome to post it on social stream, or you can also email me any questions that you have. Make sure you do complete the textbook questions for this particular chapter. So chapter 9.2 is now done for part 1 and part 2. So you can check out the part 1 videos that I've uploaded previously as well. And then I will see you back in class and have a bit more discussion on this topic as well. See you then.